Hi guys, my name is T Bao Yi and my partner is T Kai Sing. So we are going to present about 6.3 image formation by lenses. Okay, let's see the first one, which is type of the lenses. Actually, lens is a piece of transparent material such as glass, perspex or plastic. So that means the light can be passed through, so we can call as a lenses, then which has two surfaces, and at least one of the surface must be curved shape, so that one is a lenses. So you can see from the picture, the first type we call it as a convex lens. This curve outwards and are fatter in the middle. So another lens we can call it as a concave lens. This curve inwards like a cave and are thinner in the middle. Convex lens, another name we can call it as a converging lens. Converging means focusing. So later the light, when they pass through the convex lens, they will converge all the light to the focal point. So this one we can call it as a converging lens. Next one. Diverging means they will diverge. That means they will spread out. So when the light just pass through the concave lens, all the light they will diverge and spread out wider area from the focal point. Okay, now we are going to recommend about the convex lens first. Focal length of the convex lens is real because refracted light rays converge at the point, so that means we can capture on the screen, and the focal length is set to be positive because you can focus the image, so that means that the one small f, we take it as a positive length. Next, focal length of concave lens is factor because refracted light rays appear to diverge from this point. As such, focal length is said to be negative, so from here we know for the concave lens, all the bigger f and the smaller f, there is a negative value. Okay, so next we're gonna learn some optical terms. The first one is optical center. It is a point at the center of the lens. Light rays passing through the optical center are not refracted. Second one is principal axis. It is a straight line through the optical center of the lens and the center of the curvature of both surfaces of the lens. Next one is axis of lens. It is a straight line through the optical center and perpendicular to the principal axis. And next, object distance. It is a distance between object and optical center of a lens. And next is image distance. It is a distance between image and optical center of a lens. And next is focal point. It is a point where all rays parallel to the principal axis converge to or diverge from. Next is focal length. It is a distance between focal point and the optical center of a lens.
Okay, this setup will help us to investigate the behavior of light as they pass through a thin converging lens. So I have a parallel beam of light here. When I place a thin converging lens here, the ray that is parallel to the principal axis, it will bend and cut the focal point. And the ray that cuts through the optical center, it will go straight through without bending. Okay, when I place a diverging lens here, the ray will diverge outwards. And if you were to trace back the ray, this point where the ray will converge, this is the principal focus or the focal point.
To determine the focal length of a convex lens by focusing a distant object. Apparatus required. Double convex lens. Convex lens stand. Glass screen fitted with stiff white cardboard. Meter scale. Procedure. Locate some distant building or a tree from the window of your laboratory. Place the meter scale in the direction of the object. Place a convex lens duly mounted on a lens stand vertically along the meter scale such that the midpoint of its base is at 5 cm mark. Place the white screen behind the lens such that the base of lens stand and screen remain in line with scale. Move the screen backward or forward till a sharp, inverted and diminished image of the distant object is formed on it. Read and record the position of the lens and the screen by looking vertically down at the midpoint of their bases when a well-defined sharp image is formed on the screen. The distance between the position of the lens and screen is equal to the focal length of convex lens. Record the focal length of lens. Repeat the experiment by placing convex lens at 10 cm, 15 cm and 20 cm marks, and in each case, record the focal length. Calculate the mean or average focal length from the data.
Okay, now we need to introduce the ray diagram. Actually, every lenses we got 3 rays we need to learn. Let's see the first ray of convex and concave lens. The first ray is the most easier one because they just got one line. From the object straight forward to the center, then go straight. For the concave also the same. So the explanation also same. Ray which pass through the optical center travels in a straight line through the optical center without being refracted. So that means they just got one line. They don't have any refracted to other line. Maybe they have refraction, but the refraction in the same line. Okay, then we go to the second ray. For convex lens, we got in front, we got behind. Normally we use the behind one. Behind is the positive one, so the in front is the negative one. For concave lens, we are using the in front one. This is a negative. So for the second ray, we must start with the parallel line. The parallel from the head of the object goes to the center. This one we call the vertical center line. Then the ray will go to find the focal point. Okay, the explanation for convex lens is ray which is parallel axis is refracted and pass through the focal point. Okay, the concave also the same, start with the parallel line, but this one they will diverging from the focal point. So they are using the in front F, the negative one. The explanation is ray which is parallel to the principal axis is refracted and appears to come from focal point. So the difference is one is pass through, one is come from. Let's see the third ray of convex lens and concave lens. For the convex lens, the ray will go to the F first, and after go F, they will parallel. The explanation is ray which pass through the focal point is refracted parallel to the principal axis. For the concave lens, the ray will also go to the F first. When they reach the axis of lens, they will continue go to the F using dotted line. After that, from the axis of lens, they will go parallel. Okay, the explanation is ray which travel towards focal point is refracted parallel to the principal axis. Normally, the F of the convex and concave lens, they will opposite. If the convex using the in front F, then the concave using the behind F. So this is formation of image by conserved length. The first one is object and infinity. The ray diagram shows the red ray is passed through the optical centre, travel in a straight line through the optical centre. The orange ray is passed through the focus point and reflected parallel to the principal axis. The image position is image distance v equal to f, image at f. The characteristics of image have real inverted diminish. The second one is object O beyond 2f. The ray diagram shows the red ray is passed through the optical centre, travel in a straight line through the optical centre without being reflected, and the orange ray is parallel to the principal axis, is reflected and passed through the focus point. The image position is image between f and 2f. The characteristics of image is real inverted diminished. The third one is object O at 2f. The ray diagram shows the red ray is passed through the focus point, is reflected parallel to the principal axis. The orange ray is parallel to the principal axis, is reflected and passed through the focus point. The image position is image distance v equal to 2f, image at 2f. The characteristics of image is real inverted and same size as object. The next one is object O between f and 2f. The ray diagram shows the red ray is parallel to the principal axis, is reflected and passed through the focus point. The orange ray, which passed through the optical centre, travels in a straight line through the optical centre without being reflected. The image position is image beyond 2f. The characteristics of image is real inverted magnified. The next one is object O at f. The ray diagram shows the red ray is parallel to the principal axis, is reflected and passed through the focus point. The orange ray is passed through the optical centre, traveling in a straight line. The image position is image at infinity. The characteristics of image is virtual upright magnified. The last one is object O between f and optical centre. The ray diagram shows the red ray is parallel to the principal axis, is reflected and passed through the focus point. The orange ray is passed through the optical centre, travel in a straight line through the optical centre without being reflected. The image position is image beyond object. The characteristics of image is virtual upright and magnified. This slide is talking about formation of image by concave length. The first one is object O beyond 2f. The ray diagram shows the red ray is parallel to the principal axis, is reflected and appears to come from focus point. The orange ray is passed through the optical centre, travel in a straight line through the optical centre without being reflected. The image position is between optical centre and focus point. The characteristics of image is virtual upright diminished. The next one is object O between f and optical centre. The ray diagram shows the red ray is parallel to the principal axis, is reflected and appears to come from focus point. The orange ray is passed through the optical centre, travel in a straight line through the optical centre without being reflected. The image position is between optical centre and focus point. The characteristics of image is virtual upright and diminished. The next slide is talking about magnification. The photo is show the formula for linear magnification. The formula is linear magnification equal to image distance divided by object distance, and it is also equal to size of image divided by size of object. The last one is formative practice 6.3, and this is the picture given. The question 1 is what are the characteristics of the image? The answer is virtual upright and magnified. Question 2. Draw a ray diagram to show how the image in the figure is formed. The answer is because it is magnifying glass, a converse lens so it can make an object appear much larger than it actually is. This will work when the object is placed on the distance less than the focus length from the lens. The question 2 is suggest a suitable position to place the object to produce an inverted image. The answer is object located distant more than 10 cm. So that is all for us. Thank you.